In this lecture, we're going to look at an example of a three-part inequality. Let me just start out by looking at an example. Now, oftentimes these are called double inequalities because we do see that there are two inequality symbols. Now, this looks a little intimidating at first, but don't let it be intimidating. It's actually pretty easy. Let's just go ahead and cover up the left-hand side, and notice we have the simple inequality x minus 4 less than or equal to 9. We've already learned how to solve that one. On the other hand, if we cover up this side, we have negative 2 is less than x minus 4. Again, a pretty easy inequality to solve. What we're going to do is our goal on this problem is to isolate the variable in the middle. And I'll put that in quotes. And what I mean by middle is in between the two inequality symbols. Okay? So we want to get x by itself right here. Let me go ahead and rewrite. Okay. Now, what we want to do is get that x by itself. So we want to get that negative 4 out of there. Well, what you did before, when we just had this one, is you just added 4 to both sides. Okay? What you did when we had this problem is you added 4 to both sides here, and that's what we're going to do. We're going to add 4 to all three spots here. Now, remember, when I add to both sides of an inequality, it does not affect the direction of the inequality. So this is going to stay a less than. Okay, so negative 2 and a positive 4 here is a positive 2. Less than x. Notice the 4's are going to disappear. And again, adding 4 to this side of the inequality does not affect the direction. And 9 plus 4 is 13. So my solution is x is greater than 2, less than or equal to 13. Now, you'll probably be asked to write that in interval notation. So let's go ahead and first put this on a number line, and then we'll come up with the interval notation. Okay? Let me get a reference of maybe the 0 here. Maybe 2 is here, and maybe 13 over here. All right. Now, I want all x's that are greater than 2, but strictly greater, so I need an open. And I need them less than or equal to 13, so I'll have a closed. And I need all points in between. So there's the graphic solution. And the interval notation for that is simply all points between 2 and 13, including the 13, not including the 2. All right, let's do another example. Maybe a little more complicated, but still our goal remains. We want to isolate the variable in the middle. That means we want to get the m by itself right here. So a couple things we need to do. The first thing we need to do is get rid of that 4. So let's subtract 4 to all sides here. Again, subtracting does not affect the direction of the inequality symbol. So 6 minus 4 is 2. Less than or equal to, and now these 4's cancel. I'm left with a negative 2m in the middle. Again, the direction of the inequality is unaffected by subtraction. So by one step, I've got rid of that 4, and now I have negative 2m in the middle. But that's not what we want. We want an m in the middle. So to get rid of the negative 2, I divide by negative 2 to each side. Okay, 2 divided by negative 2 is negative 1. Now, remember, when we divide or multiply by a negative number, that's going to change the direction of our inequality, or it's going to flip. So this less than or equal is going to become a greater than or equal. Negative 2 divided by negative 2 is positive 1, so we just get an m in the middle. 8 divided by negative 2 is negative 4. And again, since I'm dividing by a negative, it's going to flip or invert the direction of the inequality. Okay. Now this looks a little strange. Traditionally, we like to write from left to right on the number line. Notice negative 4 is left of negative 1. So I'm going to rewrite. How about if I write the negative 4 first? I just have to make sure that all my inequalities are pointed in the correct direction. Let's see. The less than part is pointed towards the -4, so I have to keep that in that direction. The m is in the middle, and that's on the greater than side here. Again, this one, the less than is pointing towards the m, and the greater than is pointing towards the -1. Notice these are exactly the same. Okay, but this is a little nicer because I'm going from left to right. I have m is greater than -4, but less than or equal to -1. Let's go ahead and look at this solution on a number line. And then we'll write the interval notation. Maybe here's 0. I always like to put a reference point of 0. -1 is here. -4 is there. So let's graph the solution. I need all m's that are greater than -4, so I need an open. I need to go in this direction, but I need all points that are less than or equal to -1, so I'll put a closed. So there's my interval solution on the number line, and of course the interval notation is -4 to -1. Okay? So that's all there is to these triple inequalities, or sometimes called double inequalities or three-part inequalities. Lots of terminology for them. But the main thing is we want to isolate the variable in the center by just moving things around.